Welcome to the Explainer. We are jumping right into something truly fascinating today, the SASB standard for the metals and mining industry. But look, we aren't just staring at your typical financial spreadsheets today. No, we are taking a deep dive into geographic accountability. We're going to map out exactly how the world's massive mining operations interact with the absolute most sensitive areas on our planet.
So it really comes down to this core question, right? How do we measure a mine's true geographic footprint? For decades, corporate accountability was pretty much confined to the financial ledgers, just dollars and cents. But this SASB standard, it forces a massive shift. It literally pulls the focus right off the balance sheet and drops it onto a real-world map, tracking the exact proximity of these physical resources to some of the most sensitive, highly debated areas on Earth.
Okay, let's dive into this. Here is our roadmap for today's Explainer. First, the new mining map. Then, calculating the reserves. Number 3 is the 5-kilometer tripwire. Then we'll hit Zone 1, protected habitats, Zone 2, active conflicts, and finally, Zone 3, indigenous lands.
Let's kick things off with Section 1, the new mining map setting the global standard.
Now, this SASB framework doesn't just politely ask companies to, consider the environment. It forces them to mathematically map their underground reserves against very specific global boundaries. The precise reporting codes are what dictate this accountability. Under biodiversity impacts, we've got EM-M-160A.3, and then further down, for security and human rights, we see EM-M210A1 and 210A2. These absolutely aren't vague suggestions, they are strict, standardized requirements telling companies they have to report the exact percentage of their reserves sitting in these sensitive areas.
Moving right along to Section 2, calculating the reserves, proved versus probable.
So before we can draw any of these maps, we have to know exactly what's actually buried in the dirt. SISB requires companies to report their resources in two very distinct categories. First up, we have proved reserves. These are spots where the size, shape, depth, and mineral content are super well established from really detailed sampling. Then, you have probable reserves. These have a lower degree of assurance. Basically, the sampling sites are farther apart, but there's still enough data to safely assume the minerals are continuous. But here's the crucial part. For both of these categories, SISB demands that companies calculate and report the exact percentage by total weight and by grade. And by grade, we just mean the precise metal content.
To really show you how rigorous this reporting gets, let's break down the formula. Step 1, you identify the sensitive geographic boundary. Step 2, calculate the exact tonnage of proved and probable reserves inside that specific zone. And Step 3, you divide that by the company's total global reserve tonnage. What you end up with is a highly transparent percentage metric. It's basically converting physical dirt and rocks buried miles underground into an undeniable corporate accountability metric. Pretty wild, right?
All right, Section 3, the 5-kilometer tripwire, defining near.
Now, you might be wondering, what does it actually mean for a mine to be quote-unquote near a sensitive area? Well, this is where the framework introduces a totally non-negotiable threshold, 5. The SASB standard explicitly, literally defines near as being within exactly 5 kilometers.
You can really think of this 5-kilometer radius as a literal tripwire for compliance. If the outer edge of a company's proved or probable mining reserves touches a boundary line that is within 5 kilometers of a sensitive zone, bam, that tripwire is crossed. And all that rigorous percentage math we just talked about instantly kicks in. There's no guessing, no subjective interpretation. It's 5 kilometers, full stop.
Which leads us to Section 4, Zone 1, protected habitats.
Let's take a look at exactly what happens when that tripwire gets crossed by environmental boundaries. The sheer scale of global environmental tracking required here is honestly massive. Companies have to overlay their mining maps against sites that hold protected conservation status. We're talking IUCN protected areas, Ramsar wetlands, UNESCO World Heritage sites, and Natura 2000 sites. If you cross that 5-kilometer line near any of these borders, the report is triggered.
But get this, it goes even further than just static borders. The standard also factors in endangered species habitats based on the IUCN Red List. And here is a truly surprising detail for you. A species is considered extant in an area even if it merely uses it for passage. So that means if a critically endangered migratory bird routinely flies over a zone within 5 kilometers of your mine, yeah, you've crossed the tripwire. You absolutely must report those reserves.
Next up, Section 5, Zone 2, active conflicts.
Obviously, mining operations don't exist in a political vacuum. But to remove all subjectivity and bias from reporting on geopolitically sensitive zones, the standard points to a very exact, highly impartial metric. It uses the Uppsala Conflict Data Program's definition, which says a conflict is deemed active if there are at least 25 battle-related deaths per calendar year. It doesn't matter who is fighting or why. If the math hits exactly 25 deaths, that area is officially an active conflict zone.
Now, for active conflicts, that tripwire actually expands way beyond just 5 kilometers. Reserves must be reported if they are located in the exact same country as the active conflict. Furthermore, even if the mine is in an adjacent state, if it can be reasonably expected to be operationally affected by the conflict right next door, those reserves must also be calculated and disclosed.
Moving on to Section 6, Zone 3, Indigenous Lands.
This final map layer focuses heavily on operations near vulnerable traditional communities. And just like with the conflict zones, the SASB relies on completely impartial, globally recognized definitions here. It uses characteristics outlined by the UN and the International Labor Organization. This includes things like historical continuity to pre-colonial societies, distinct languages, and strong links to natural resources. If a mining reserve sits anywhere within that 5-kilometer tripwire of these recognized ancestral boundaries, it has to be reported.
And really, that brings us to the core purpose of metric EMMM 210A.2, and honestly, this entire SASB standard. It ensures absolute transparency. It forces an objective, mathematical light onto the very real geography of global mining. This isn't about halting mining, and it definitely isn't about endorsing specific viewpoints on global disputes. It is simply about explaining the source material of our global supply chain through crystal clear, undeniable, percentage-based data.
Which leaves us with a final thought to ponder. The metals powering the very screen you are looking at right now came from somewhere on that map. Knowing what we know now about proving reserves, calculating exact percentages by weight and grade, and those unseen 5-kilometer tripwires, how will this exact geographic data change the way you look at the metals inside your everyday devices? Thank you so much for joining me for this explainer. Keep asking questions, and I will catch you next time.